Now that we've learned about the basic 6 trig ratios, we're going to extend that to looking at it on our coordinate plane. So something important to think about is I'm going to start on the positive x-axis, and I call that 0 degrees, and I rotate counterclockwise. So then this would represent 90 degrees. Another 90 rotation would be 180, and then 270 degrees, and all the way around would be 360 degrees. So the first thing that we're going to do is you'll be given a trig ratio and what quadrant it's in. Once you're given the quadrant, then you're going to draw one of these 4 triangles. 1, 2, 3, 4. Aren't those beautiful? You may notice they look kind of like a bow tie, so I refer to these as the bow tie. So my first thing is decide what quadrant, and that's the part of my bow tie I'm going to draw. And you put your angle always attached to the x-axis. So you should always just draw your bow tie and decide what quadrant. For instance, if I decide that I'm in quadrant 4, then that means the triangle I'm going to draw is going to be in this orientation, with theta always next to the x-axis. So our steps are written up here in the corner, and there's not a spot for you to really write this if you just want to write it somewhere on your paper. We're going to decide the quadrant, 1, 2, 3, or 4, and draw that triangle, that part of the bow tie. Find the missing side that they didn't give you, check your signs, and answer the question. What does it mean by checking signs? If you think about your normal coordinates on the coordinate plane, in the first quadrant, your x is positive and your y is positive. In quadrant 2, your x is negative, y is positive. Quadrant 3, both x and y are negative. And in quadrant 4, x is positive, y is negative. So for instance, with this triangle I already drew, my x direction would be a positive value, and my y direction would be a negative value. So let's look at some examples. Hopefully this is the first one on your page. Sine of theta is 3/5, and we are given an angle between 0 and 90 degrees. So that means we're talking about quadrant 1. So if I imagine my little bow tie, I want the bow tie part that's in quadrant 1, which is kind of like your normal quote-unquote right triangle that I have drawn right here. Now, I didn't write down the question. I think that this is asking for tangent of theta, but if it works for, you can find tangent, you can find whatever you want. So, sine is opposite over hypotenuse. So I label my triangle. This would be opposite. Here's my hypotenuse. Here's my adjacent. My opposite side, it says, is going to be 3. My hypotenuse is going to be 5, and you might know this one's a Pythagorean triple. I'm just going to call a is my x. So x squared plus 3 squared equals 5 squared. At this point, it seems like the problems that we did for the other triangles. So I get x squared equals 16, x equals 4. Now check my signs. X and y are both going to be positive because we're in quadrant 1. Now I'm going to answer the question, which is what is tangent? Tangent is O over A. So my opposite is 3, and my adjacent is 4. Once again, I think that's the problem you have on the page. I accidentally did not copy that down. Let's look at another one. Find cosine of theta if sine of theta is 2/3 and your theta is between 0 and 90 degrees. So on my coordinate plane, 0 is positive x-axis, and then 90 degrees. So that means we're talking about quadrant 1 again. So if I label what I'm given sine of theta, which is O over H. So my opposite side is 2, and my hypotenuse is 3. So I can find my third side, x, by doing x squared plus 2 squared equals 3 squared. So x squared plus 4 equals 9, x squared equals 5, so x equals 5. Once again, we're in quadrant 1, so both my x and my y are positive. And I'm just going to quickly label my H, O, A. So I want cosine of theta, which is A over H. My A is 5, and my H is 3. Sorry, square root of 5. Square root, beep, beep. How did I know that was wrong? Because cosine and sine should both be less than 1. Good way to check. Find tangent of theta if sine of theta is 3/7 and our theta is between 90 degrees and 180. So 90 and 180 is telling me I'm talking about quadrant 2. So if I think about my bow tie, I want this top left triangle. Theta always adjacent to the x-axis. So we're given sine again over h, so my O is 3, and my hypotenuse is 7. So I need to do my Pythagorean theorem. We're still solving for x this time. X squared plus 3 squared equals 7 squared. So x squared plus 9 equals 49. X squared equals 40. So x equals square root of 40. And we're just going to leave that. I don't need you to simplify right now. Okay. But what I need to think about is my signs. In quadrant 2, my x value is going to be negative. And that's going to affect my final answer because I'm trying to find tangent. Tangent theta is opposite over adjacent. If I label HOA, HOA, my opposite is 3, and my adjacent is negative square root of 40. So really the only thing that's changing from prior trig problems is I'm going to have some negatives thrown in here sometimes. Okay, now we're going to add 2 more things. Find all of the ratios, sine, cosecant, cosine, secant, tangent, and cotangent. If cotangent is 5 over 12, and theta is between 180 and 270. So 180, whoops. (180) and 270, that means we're talking about quadrant 3, and there's the piece of my bow tie, and there's theta. So we're given that cotangent is 5 over 12. Now, I don't really like thinking about cotangent. I like thinking about tangent. So if cotangent is 5 over 12, that means tangent is the reciprocal. Flip it, 12 over 5. And tangent I have memorized as O over A. Plus, I'm going to have to answer that anyway later, so I might as well do it now. So opposite would be 12, and adjacent would be 5. But we're in quadrant 3, so both my x value and my y value need to be negative. Then I need to solve for my last side, so 5 squared plus 12 squared equals my hypotenuse squared, and that's going to give me 169 equals h squared. H equals 13. You might recognize that as a Pythagorean triple, which makes these a lot faster. Label your HOA, HOA, and now it's a simple thing of going back to SOHCAHTOA. So sine is O over H, so negative 12 over 13. Cosecant means I flip that, so 13 over negative 12, or negative 13 over positive 12. Cosine is adjacent over hypotenuse, so negative 5 over 13. Secant means you flip that, so 13 over negative 5, or negative 13 over positive 5.